Moving on to 1.7, literal equations. You may be asking, what is a literal equation? How many of you asked that in your head? Only 2 of y'all? Everyone else knows what a literal equation is? Okay. An equation that has 2 or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variable or variables. So a literal equation is an equation that has 2 or more variables. Can I go ahead and move on, or are we still writing? Okay, I'll wait a little bit. So we're just going to use our inverse operations today to manipulate the equation to solve for one of our variables. It'll let us know which variable to solve for, so we're just trying to get that variable on one side of the equation by itself using our inverse operations. So example 1, solve the literal equation 3y plus 4x equals 9 for y. Just solving this equation for y, trying to get the y by itself on one side of the equation. So can anyone raise your hand if you think you have an idea of what my very first step is going to be to get y by itself, Cayman? Not quite. Not yet.
Subtract 4 on both sides.
Say what?
Subtract 4x on both sides.
Very good. I'm going to subtract 4x from both sides. So I get 3y equals negative 4x plus 9. Now what do I do? Divide by 3 on both sides. When I divide this right side by 3, I have to divide each term by 3. Does everyone see that? So I get y equals negative 4/3 x plus 3. Is that equation now solved for y? Yes, it is. There's my answer. Any questions there? We good? Not too bad? Can I go ahead and move on to the next slide? So here's just a few more examples. Solve the literal equation for y. So for the first one, 3y minus x equals 9. What would my first step be? Add x to both sides using our inverse operations. Can I combine 9 and x?
No.
Why?
They don't have the same, they're not like terms.
Very good, they're not like terms. So I just get x plus 9. And then my last step. Divide both sides by 3. So I get y equals 1/3 x plus 3. And now my equation is solved for y. Any questions with number 1? Number 2. It's my first step here. I could add 2y to both sides. Get 2x equals 2y plus 5. Now what would I do? Where could I go from there? Not divide yet. I don't want to divide until I get the y term by itself. So I'm trying to get 2y by itself. So what do I need to get rid of before I can divide? The 5. So how do I get rid of that 5? Subtract 5 from both sides. So 2x minus 5 equals 2y. And now what can I do? Divide both sides by 2. So I get x minus 5 halves equals y. My equation is now solved for y. Any questions on number 2? Yes.
We need to reduce 5 to and like 2 and 1 half.
So if you wanted to write 5 halves as a mixed number, you could. Or if you wanted to write it as a decimal, you could. Or you could write it like this, as an improper fraction. Because this is reduced all the way as an improper fraction. So I could leave it like that. Does that make sense? Other questions? Okay, number 3. 20 equals 8x plus 4y. What would be my first step here? Subtract 8x from both sides. Negative 8x plus 20 equals 4y. And then my last step, get y by itself. Keaton. Divide everything by 4. So I get negative 2x plus 5 equals y. And there's my equation solved for y. Any questions on anything I've done so far? Is it making sense? Just using your order of operations to solve for the variable it asks you to solve for. Or your inverse operations. My apologies. Can I move on? All right, here's a different type of an example. Solve the literal equation y equals 3x plus 5xz for x. So I'm trying to solve for x. Anyone have any ideas what I might need to do? Anyone? Yes. Subtract what? The 5xz? Well, I'm trying to solve for x, right? Trying to get x by itself. Am I able to combine 3x and 5xz? No. So I need to try to find some way where I can get just an x, or where my x's are combined, I guess I should say. Have you guys ever factored out a greatest common factor before? Or do you know what a greatest common factor is? Okay. So that's what we're going to be doing here. We're going to be factoring out a greatest common factor. So what do this term and this term have in common? An x. Is there any number besides 1 that goes into 3 and 5? Nope. So I can't pull anything out from those. And then do they have any z's in common? No. So 3x and 5xz have a greatest common factor of x. Does everyone see that? Okay. X times what would give me 3x? 3. And then x times what would give me 5xz? 5z. That would be my greatest common factor factored out. Any questions on how I got that? Does that make sense? Does everyone understand that? Now I just have 1x, correct? I've got x times 3 plus 5z. So how could I get x by itself now? Say what? Well, can I combine anything in the parentheses? No, I cannot, can I? Well, if I distribute, that's a good thought. If I distribute, though, I'm just going to get right back to where I started off, right? How do I get 3 plus 5z on the other side? Huh? Not subtraction. Let's think about the operation that's going on here. It's x times 3 plus 5z. So what? I got to divide it. I got to use my inverse operation, right?
Said that.
Did you?
No.
Okay. So if I divide by 3 plus 5z, that'll get rid of it over here. But I've got to divide y by 3 plus 5z as well. So I get y over 3 plus 5z equals x. And I could even... No, that's how I can write it. That'd be my answer. Does everyone see how we went about that? If I have two terms that I can't combine, then I need to factor out a GCF. Does everyone see that? GCF. Greatest common factor. Questions on example 2? Can I move on? So let's do some more similar to that. Number 4, y equals 5x minus 4x. I'm solving all these equations for x. Do I have any like terms I can combine? Yep. What's 5x minus 4x? X. So there's my equation solved for x. X equals y. Y equals x. That was pretty easy, huh? Questions on number 4? Pretty straightforward. Number 5, 2x plus kx equals m. 2x plus kx equals m. I'm solving for x. Can I combine 2x and kx? Those are technically like terms. I just don't know what k is, so I can't really add them. So let's go ahead and factor out a GCF. What do they have in common? X. So I'm going to factor out an x. Is there anything else they have in common? Nope. So x times what would give me 2x? 2. X times what would give me kx? Okay. Questions how I factored that one? You're just kind of doing the reverse of the distributive property. Right there. Huh?
Would we divide that then?
Yep, since I'm solving for x, I want to get that 2 plus k on the other side. And once again, since it's x times 2 plus k, I need to divide both sides by 2 plus k. So x equals m over 2 plus k. There's my answer. Questions on 5? Not too bad? Okay, one more. 3 plus 5x minus kx. 3 plus 5x minus kx. Any ideas where I might need to go from here? What are we trying to solve for? Trying to get by itself? X. So what's the only term on the left-hand side without an x? 3. So let's just go ahead and move that to the other side of the equation. How do I move 3 over?
Minus 3.
Huh?
Minus 3.
Subtract 3 from both sides. So 5x minus kx equals y minus 3. Everyone good with that? Now all I have are x terms over on the left-hand side. Can I combine them? No. What do they have in common? X. X times what would give me 5x? 5. X times what would give me negative kx? Negative k equals y minus 3. Almost there. How do I get x by itself? Not subtract, but divide by 5 minus k. So x equals y minus 3 over 5 minus k. That'd be my answer. Solve for x. Questions on number 6? Not too bad? Everyone good? Any questions before I give you the homework? Here's our homework. Page 50, numbers 4 through 26 evens. This will be due, let's say, Thursday, December 10th on Canvas. Everyone got this written down? Page 50, numbers 4 through 26 evens. Due this coming Thursday on Canvas. Friday, we are probably going to have a test in here over this past unit. So make sure you're prepared for that. Okay? I'm trying to give you all a heads up so you're not completely surprised by it on Friday. So we'll review on Thursday, test Friday. Tomorrow, you'll get an assignment on Canvas. It's a remote learning day tomorrow. I want to make sure everybody heard me. Everyone hear that? Tomorrow, there will be an assignment for you to do on Canvas. So I don't want you to come back to school Thursday and say, "Oh, we had an assignment yesterday, I didn't even see it." Right? Right? I mean, I'm giving you a heads up right now. There's going to be an assignment tomorrow on Canvas, so don't be surprised when it pops up on Canvas. Any questions?